The broadcast is now starting. All attendees are in listen-only mode.
Well, good morning, everyone. Thank you for attending our webinar today. My name's Steve Combie. I'm with Frontier Precision. I'll be the moderator during today's presentation. We have a special guest panelist with us, Mr. Dave Cantor with Timble Water, and Dave will be running the presentation today. The webinar is on Timble Water's remote monitoring system, which consists of their recording terminal units called RTUs and the Unity software. Dave will give you an overview of the whole system and how it works, and then introduce the hardware and the software that brings it all together. So I'm going to go ahead and transfer the controls over to Mr. Cantor now. Okay, Dave, I believe you're on.
Okay, great. Just want to make sure everybody can see my screen to begin with and can hear me.
Yeah, we can hear you, but we're still seeing my screen. There's a button up there to click on the show screen.
Okay, let's see if I can find that, Steve. Webcam, audio, attendee. Maybe you can point it. Can you take your cursor and point it to where that would be?
Yeah, let me see. There we go. Okay, there we go. Now we can see now we should be able to bring up your presentation. Okay. There we go.
Can you see it now?
Yes.
You can see it now. Okay, excellent. Okay. Just want to try to get one thing out of the way here. Okay. Okay, so you should see Timble Water. You can see all of that then, correct?
Yes.
Okay, great. All right, good morning, everybody. Very quickly, just let me introduce myself. My name is Dave Cantor. I'm with Timble Water. I am the West Coast Regional Business Manager. I cover California, Oregon, Washington, Nevada, and Idaho, and so we work very closely with Frontier. Frontier covers the state of Utah and Idaho for Timble Water. So they've asked me to put together a presentation for everybody on the call today. The focus is going to be our remote monitoring applications. So we will spend some time kind of going through the whole application for you. And I am just trying to see if I can get rid of one of these things in here. There we go. Okay, so yeah, so we're gonna talk about remote monitoring today, and basically remote monitoring is really comprised of a family of hardware devices that Timble offers that is connected to and associated with software. The software is called Timble Unity, and we use the Telog Timble devices. So we've got a whole family of devices that we're going to be able to show you today that can monitor remotely practically everything out in your network. So if you look at my screen right now, we're going to talk about clean water applications to begin with. So there are 5 different areas that we can monitor inside a water distribution system. That would be flow, a couple of different points of pressure, level, and we can monitor pump stations. So there are many, many applications for it. So for flow, we have flow meters that can work with non-revenue water, night flow analysis, district metering, and billing. We can also work with pump stations, a variety of different meters to bring in data from mag meters. We also have the ability to connect to a variety of water quality sensors like pH, conductivity, turbidity, chlorine. We also can monitor rainfall too. So in terms of level, we can monitor level at the well, reservoirs, watersheds, and elevated tanks. And for pressure, there's many applications that we can use for pressure. Again, water, non-revenue water. We can bring in data that will help calibrate hydraulic modeling, fire flow, C-factor testing. We can monitor for impulses. Another name for impulses is water hammers, line breaks, pressure relief valves, and pressure reducing valves, pump stations, and zone monitoring. So there are, a multitude of different applications that can be used with our devices. So this gives you kind of an overview of what we can do inside of a water distribution system. Okay, so let's talk about pressure first, because pressure is probably the most widely used application for the Timble water devices. Utilities really are trying to get a good handle on real-time pressure in their system, trying to understand, how the pressure is working, if there are any swings in pressure. It helps them really regulate the system, to its best ability and create the most efficiencies for it. So some of the things that we try to do with pressure are assessing and reducing risk. And those would be hydraulic integrity, pipe deterioration like pipe breaks and leaks, pressure transients, changes in flow, changes during maintenance and emergencies, scale or turbulation, and inadequate operation control. So the consequences are the possibility of contamination, sedimentation, reducing hydraulic capacity, meaning that increase in pump costs, poor water quality, and water age. So again, there's an awful lot of things that you can do with the data as it relates to monitoring pressure. So one of the biggest concerns that any utility has is understanding any water hammers that are occurring in their system. It's very important that utilities get a good feel and get a good visibility to any kind of water hammer impulse events that are happening, because the water hammers simply put undue stress on the pipes, and will lead then to leaks and eventually main breaks. And if you don't have a good understanding of water hammers that you might be having in your system, then you don't really have the ability to eliminate those so that it will reduce the stress on your pipes. So water hammers is a very, very important part of the application for water pressure monitoring. So there's a couple of different ways that we can monitor for pressure in your lines. Probably our largest and biggest application is what we call the HPR32A or HPR32IA. Now you can see a picture of it on the screen. It's a very, very flexible piece of equipment. It actually just screws right onto a water hydrant. And from there, it can monitor pressure in that particular line where the hydrant recorder has been placed. So we have two different kinds. One's called an A and one's called an IA. The A has the ability to bring in pretty much trended pressure recordings. The IA has a much faster processor in it and has a much higher sample rate. So it's got the ability to pick up transients that are happening in megaseconds and milliseconds. For example, the IA's got the ability to sample as high as 256 times per second. The nice thing about this device is that it's very, very easy to install. So it doesn't take a lot of effort to install it, and it's extremely mobile too, meaning that you can put it out on a location for a certain period of time if you want to do some pressure studies, or you can leave it on permanently. If you're just going to be lifting and shifting it, it's very easy to take the device off and put it on another location. And it will record and keep a history of all the data from the previous location. If you look at the picture on the right, you see that we've developed a nice security system for it. We've got a cover that goes over the top of it that can have a padlock put on it. Typically can match the color of the hydrant, so it's not so obvious to people that are looking at a hydrant to see what's going on with it. So it works very, very well. So the other way that we can monitor pressure is from our PR32 or PR32i. It does exactly the same thing that the hydrant pressure recorder does. The difference is that it's connected directly to the valve underground. So this is an ideal application, particularly in cold weather climates. If you want to be monitoring throughout the whole year and you don't want to have to pull off the hydrant recorders during your freezing periods of the year, your winter time, then this will work because it is underground, and so you're going to get continuous monitoring of pressure. It does exactly the same thing. This is the telemetry. You would just connect a pressure sensor to this telemetry right on the pipe itself, and you can get the same type of data that you would be able to get with the hydrant recorder. Now, one of the nice things about the recorders are that they're fully battery powered, meaning that they don't require any external power. Battery life tends to be at the max about 5 years. It would depend on how you configure the call-in schedules and your sampling rate, but at fairly normal sampling rates and call-in schedules, which are usually once or twice a day, you can kind of count on anywhere from a 4 to a 5 year period. Now, if you're having it call in on a very frequent basis, that's going to have impact on it. So again, it does not require any external power at all. It's all wireless communication, meaning that it is communicating through a cellular modem. And because you can get the real-time data, and this is very important to utilities, you've got the opportunity and the ability to set up alarms. So, for example, if you have, say, pressure that is at a trending rate of 100 psi, but then it jumps up maybe 20 psi or down 20 psi and stays at that level for a period of time, that will trigger an alarm, which will go out as a notification. And it would go out to anybody that is on your distribution list. It can go to one person, it can go to many people. It's got the ability to track it, and it will stay active until somebody responds to it. So this way you don't have to go out on location to get the data. All the data will be available to you through our web application, which is called Timble Unity, which we will show you a little bit in a moment. Or you actually can get the data through a mobile application as well. So just want to kind of give you a screenshot of what the data looks like a little bit later in the presentation. I'm going to actually show you the software itself live and how the software actually works. But this is a screenshot to give you an example. So the first shot that you're looking at, this is coming from a hydrant recorder that was put out on location. And as you can see, the pressures are very, very, very unstable. They're jumping up and down continuously, anywhere from as high as 150 psi, all the way down to 80 or 90 psi. Now, you'll notice these little rectangular icons down here that have a number on them. And what that is actually an indication of a water hammer. And what we do in the software is that the software will categorize the water hammer depending on the intensity of it. We have 5 different categorizations, one being a very minor transient all the way up to 5, which is a critical transient. So by looking at this, the operator really can see that they've really got some issues going on in this network. So and this is comes from a real case study from one of our customers. So they really had no idea what the pressures were in their system and what it was doing until they put the hydrant recorder out on location. And when they started seeing this data, it got them to investigate why this was occurring. And so what they determined was that this particular area was being fed by 2 PRVs. They went back to check the PRVs, and they were able to determine that one of the PRVs was doing about 98% of the load, and the other PRV was doing absolutely nothing. And so what was happening is that the PRV was continually opening and closing just to keep up with the demand. And by doing that, it was creating these water hammers. So what they did is they balanced out the PRVs, where they balanced the load out at about 50% each. And now you can see the results. So they went from this to this, where now they have fairly stable pressure readings, and they eliminated all of the transients. So a couple of the benefits of that were, number one, they reduced a lot of strain on their PRV, because that one PRV eventually was going to have all sorts of problems, the one that was working continuously. So they were able to save the life of the mechanisms of the PRV. And also they were taking strain off of the pipe by reducing and eliminating all the quick surges that were occurring in the network itself. So before I go on, Steve, if anybody's got any questions and they want to write in some questions to you, I'd be happy to answer them at this point. If not, I'll continue on.
Okay, thanks, Dave. Dave, we actually have 2 questions that have come in. So I'll read those and have you answer those. So the first question is are they easy to install and retrofit?
Yeah, good question. So the answer is yes. The hydrant recorders themselves are very easy to install. It's simply a matter of screwing the device on the 2.5-inch thread on a hydrant. And then you have to charge the hydrant so that water's running up through the hydrant so that it can gather that pressure information. And then you simply put the cover on it and off you go. I would say in total, it probably takes about 10 minutes to install a hydrant recorder. Now, if you want to take it off, again, the same thing. You would turn the hydrant down, you would turn the valve off, unscrew the hydrant, put the cap back on it, and then you could go and install it in another one. The software's got the ability to make the changes remotely, where you can change the location of it and put it on a different location on the map. You don't have to call the factory. to do it. It's all done in the software itself, so the customer's got complete control over the location and the configuration of it.
Okay. Thanks, Dave. The second question is the data compatible with most analysis and modeling programs?
Yes, the answer to that is yes. One of the things that data is used for is hydraulic modeling. The beauty of it is, and you know, if you talk to hydraulic modelers, they love this data. So you can actually transfer the data, export it into CSV and Excel files, and it gives the hydraulic modeler real-time information so that it can help calibrate their models. Without this data, then a lot of assumptions and models have to be set up to really get the correct pressure. And just like any kind of a model, it's a model, so it's not entirely accurate. But if they have real data, then they can calibrate their model much easier. It can also be connected and talk to just about any other third-party software. So we can connect it to asset management platforms like CityWorks, which is part of the Timble family of companies. So you can get seamless integration of this data into an asset management platform. So work orders can be set up through it. And it also can be connected to SCADA as well, too. So it's done through what we call APIs. And so APIs are just a web-based interaction and interface between third-party or different types of software that can then start to talk to each other. So it's something we do all the time with all sorts of different software and analytics that are out in the marketplace right now.
Great. Thank you. I believe that's all the questions we have at this point.
Okay, that's great. So let me now go to our multi-channel recorders. The first one I'm going to show you is an RU32MA or an RU32IMA. Again, the difference between the M and the I is that the I's got the ability to monitor and to capture high intense and very fast water transients or water hammers. So the application for the 32 is primarily, we use it, or a lot of our customers use it for monitoring at PRVs. So this is an excellent application to be able to monitor a PRV. So I'm sure a lot of the audience and their utilities do have SCADA, and SCADA does do a lot of work for them, but one of the blind spots and one of the weaknesses of SCADA is that you have to have power to get SCADA set up. Now, PRVs are typically set up remotely throughout a network, so it's very expensive, not very efficient to run power to all these remote PRVs. Because our devices are battery powered, then it doesn't require power to be able to monitor your PRVs. So utilities really have, in the past, if they don't have SCADA set up and they don't have power set up at the PRV, they're sort of operating in the blind, and they really don't have very good visibility into the operations of their PRVs. And so by being able to put our battery-powered multi-channel device, the RU32, at a PRV, you can get real-time data, and you can be setting up alarms and notifications when the operations and the PSI levels are starting to drift out of range. And so you become then very proactive. So typically what will happen if you don't have any way of monitoring what's happening at your PRV, you almost have to wait for an event to happen. And by that point, it's already could be some sort of a catastrophic event. Meaning if a PRV fails, that's going to impact all the pipe going down the line. It could create many bursts. It could create all sorts of havoc at customers' homes by high pressure coming into their houses. And this gives you the ability to monitor pressure inlet, the high side, and monitor on the outside. The other nice thing about this device is that, again, it can be connected. There's about 7 different channels that you've got the ability to connect devices to. So probably one of our most widely used application is connecting a flow meter to the RU32, and also connecting pressure sensors to it too. So you can get flow data, inlet pressure, and outlet pressure all from one device. So again, battery powered, has the ability to set up alarms. It's got wireless communication, so you can get the data remotely. Again, it's got about a 5-year battery life. It does require an external antenna. We've got a wide variety of antennas that will work depending on what the actual installation site looks like. So again, a very, very good application. Probably one of our most popular and one of our most used pieces of telemetry. So let me just show you a screenshot of what that would look like. So you're looking at 3 data points. So if you look at the red line, that data point is the inlet pressure coming in. If you see the blue line, there's a flow meter connected to this. And so that's bringing in flow data. And then if you look pretty much at the straight line, it's a little bit, don't know if you can really see it, but it's where my cursor is pointing right now. And that's the outlet side right there. So again, this is really bringing in some very important data points to the operator. It's bringing inlet flow, inlet pressure, bringing in flow, and then the outlet pressure as well too. So the example that I'm going to show you right now is this is sort of the before. This is what the data looked like when they first installed all the equipment. Then after a period of evaluation, what they were able to determine is that their pumps were running almost continuously when the demand was not there. So you can see a completely different view of it right now. So what they essentially did is they correlated the demands that they were getting, and they started to adjust their pumps to meet the demands when it was required, but then to back off the pumps when the demand was not there. So you can see if I take when the flow went down to practically nothing, this is when they were able to turn down the pumps because the demand was not there. And then, as you can see, when the pressures went down on the high side, demand went up, and the pumps reacted and started pumping water through the system at that point, and again brought it down. So they were able to actually reduce their pump run times by about 25%, which really equates into, a significant savings from energy. I probably don't have to tell everybody on the phone or on this conference that one of your biggest line item is expenses is energy. So if you can get a good handle and reduce your energy cost, it's going to bring down the cost of your operations dramatically. Okay, so this is a booster pump outlet. Let's go on to the next one. So a booster pump outlet, again, this is with a RU32. So this is bringing in line pressure and flow rate at the same time. So one reading for line pressure, which is the green line, and then the flow rate. So again, this is done with one of our multi-channel devices, the RU32. So let's take a look at wastewater now. Now there are many other applications for water and for wastewater. As I think, just for the sake of time, I don't have the opportunity to show all of them to you. but I wanted to really highlight some of the most widely used applications. So for wastewater, let's take a look at wastewater and see what we can do. So wastewater, some of the applications are for inflow and infiltration. We can bring in flow data and rain data. Open channel flow, we can monitor flow, pressure, level, and we have the ability to monitor for water quality. And then at a lift station, we can monitor pump levels, pump run times, flow through the station. We can set up alarms. It does not require power, but it will notify of AC power failures. We can monitor for flow blockages and discharge pressures as well too. Again, keep in mind, everything is battery powered. So there's no AC required at any of these sites. Now, oftentimes, again, SCADA usually is pretty well set up or can be set up, but that's more at the vertical assets like pump stations and lift stations and treatment plants and so forth, but not necessarily out in the collection system itself. So this is where the Timble product comes in nice and handy and adds as a great complement to SCADA systems. So let's look at a couple of these devices. So let me show you what's called the RS-33. It's a series of available multi-channel devices. There's 3 different kinds. There's one called the 3307, which has 7 inputs, 3314, which has 14 inputs, and then a 3330, which has 30 inputs. Again, it's all battery powered. Now, you do have the ability, though, if you want to add additional power, an external power source to it, is that we can connect to a solar panel, which will continually power the system. So again, the applications are at pump stations and lift stations for performance, custody transfer, flow, and wastewater quality as well. This is our rain gauge. Again, the rain gauge is a great product that can be used remotely. It's connected to a tip bucket. When the tip bucket tips, it's going to bring in data and it's going to show you what the rainfall is in real time. That will have impact on your wastewater system too. Okay. And the RU35. So the RU35 is really sort of the, I would call it, this is our main application. So the RU35 is a rugged device. It's designed to go into harsh underground environments. You can connect six different sensors. Analog sensors, digital sensors, and common sensors as well. It can read a variety of different things. It can be used to connect to just about any kind of sensor in the marketplace, whether it be ultrasonic level, temperature, velocity. Again, it talks Modbus. It's got all sorts of different inputs to it. Water quality is another sensor that can be connected to the RU35. So this is really the workhorse for anybody that has got a wastewater system that wants to bring in a variety of different data points for it. So these are some of the sensors that are compatible. You have ultrasonic level sensors. You've got pressure level sensors, area velocity sensors. So we support just about any manufacturer in the marketplace, and we've worked with all the major manufacturers, including Hawk, as an example, and flow wave sensors, and just about every major manufacturer in it. And if we haven't worked with them before, it just requires a little bit of testing to make sure, and certification that'll make sure it will work with that. The RU35 will work with that particular sensor. So it's very flexible. So that's kind of a quick overview. Again, I'll stop for a moment, Steve, to see if there are any other questions out there.
Okay, let me check our question pane here. Okay, two more. Are the recording and telemetry units waterproof?
Yeah, well, so it depends on the particular telemetry unit. The highest level of waterproof is what's called an IP68. That's the certification, the waterproof certification of it. Any sensor that has the risk of being exposed to water if it's underground is an IP68. So it is submersible, right? Meaning that the unit can be submerged in water for a certain period of time. Now, we're not recommending that it stay submerged underwater for hours or days, but typically speaking, it's got the highest rating that's available on the market for being waterproof, which is IP68. Some of the other devices, which are typically not exposed to water or flooding, but maybe exposed to rainwater, for example, are what's called IP67. So that, again, is waterproof. It's just not quite at the same level as the underground devices. So the answer to the question is yes, they are waterproof.
Okay. And then one more. Do I set up the self-service or does Timble do this?
So there's a couple of options. For the most part, probably 95% of our customers have Timble set up and manage all the cell accounts. So we do that. We will do that for the customer. They don't have to worry about anything. So we manage the accounts. It's included, the cost of the cell service is included in your annual subscription for the software. So there essentially is nothing that you have to do. Now, some customers, some of our larger customers like to set up their own accounts, and you've got the ability to do that. But like I said, I would say, well over 95% of our customers have Timble manage the cell service for them.
Okay, great. Thank you. So that's all for now. So we'll let you proceed with the Unity.
Okay, great. So that was an overview of the hardware. Now I want to talk about the software. So each piece of hardware is connected to and associated to what we call Timble Unity. Timble Unity is our software platform for capturing the data and managing all the field operation and critical assets out in the field. So it is GIS centric. I would say almost all of our customers are with Esri, and so we are an Esri partner. So we can work directly with the GIS department to bring in GIS data to the system and interface with GIS. So it's got both a cloud and mobile software, meaning that it's web-based and also mobile-based. It does support smart water management, meaning that it has a multitude of applications, not just for remote monitoring, but for many other applications like workflows in the field, things like inspections and repairs. It would get the utilities off of paper work orders that become very cumbersome and very inefficient. We can digitize everything, so everything can be connected with remote monitoring and also with workflows. It definitely improves your business processes. And the software will help you with regulatory compliances, meaning that it can be set up to create reports that you have to submit to state or local regulatory agencies. So the software itself is going to provide you with real-time operational awareness of everything that's going on. So it will monitor and optimize your water and wastewater operations. It's going to help reduce infrastructure failures and repair costs. So I think the best way to kind of look at our overall solution is this is going to move you towards becoming a proactive utility as opposed to a reactive utility. So what typically happens is that utilities have to wait for an event to happen, and then they have to mobilize and go out and take care of that event. And it's more of a triage event. So it can be very costly, very expensive. It creates a lot of health and safety issues, and people are having to work out in the street in the middle of the night if there's a water main break. What this data is going to help you do is it's going to help you give you the operational awareness that you need to identify problems before they become major problems. So I think the best way to look at the overall solution is that this is moving you towards becoming a proactive versus a reactive utility. So that's the end of the presentation, but what I wanted to do is I wanted to, before I do that, I don't know if you've got any other questions right now, but what I want to do is to dip into the software right now. And Steve, if everybody can see my screen.
Yeah, go ahead and run the software, and then we'll save the last questions to the end.
Okay, great. Okay, so this is what the software looks like. This is your kind of opening page into the software. You're going to log in. You're going to get a screen with a whole bunch of different icons on it. And the icons are going to direct you to what the application it is. So what I clicked on in the previous screen was the remote monitoring application, and it brings me to my screen. So again, it will show you all your locations over here in a list if you look down through them, but it also will show you those locations on a map. And then this is actually showing workflows and work orders that are out in the field right now. So let me take you through a couple of different sites with different applications. So the first one that I'm going to click on is water pressure. So once I click on that, it's going to bring me to where that location is on the map. So you can see the site on the map. Now again, this can all be connected to your GIS. So all your GIS assets can be on this map as well. It's not mandatory. If your GIS is not on here, it would be more or less just a typical Esri base map, which would look something similar to like a Google map, for example. So you've got a bunch of different views of the base maps. You've got an aerial, a topo, and you've got a street map as well too. So this is going to identify the site, what the site is monitoring, its water pressure, the type. It'll tell you if it's in service, a description of it. It'll give you some battery strength. Battery strength is good. One of the nice things about the software is it's got the ability to monitor your battery because you really don't want to wait for battery to die, and then you're going to lose that data from when the battery dies to when you go out and replace it again. So this gives you the ability to monitor the strength of the battery. It's going to show you the call status, which is normal. And it also will tell you when the last call was and when the next call is scheduled. Now, we do have what's called a dashboard. So let me take you to the dashboard. So the nice thing about the dashboard, and this is very good for like supervisors and superintendents or general managers. General managers can go in, and if they want to just check the system on a daily basis, so they don't have to dig into each location. It'll bring up a dashboard, and it will give you an indication of what's going on. So for example, it's showing one alarm. So if I click on the alarm, it'll drill into that alarm and give me the information on it as to the activation of it. It will give alarm activity over the last 7 days, whether they were high, low, or low alarms. Again, battery strength, which is very important. So when you start to see this red circle come up in certain areas, it's going to tell you that that battery is getting very close to dying, and you want to take action and go out and replace the battery before it does die. Gives you a good call status information. So this shows 17 sites. All sites were calling in on time. If sites are not calling in on time, it'll tell you which sites are not calling in on time. And then it also will give you an overview of the impulses. So it says we've had 10 water hammers in that in this particular period of time. 3 of them were critical, 2 were major, 3 were moderate, and then 2 had no impulses at all. So if you want to drill in, you can drill into the high pressure areas that have shown critical water hammers. It gives you sort of an indication of what they were, and you can bring them up and look at them. So it really is very helpful for getting a quick overview of the health of your system. So let's go back and look at this one site. So we set up what's called a default report. A default report can be set up any way you want in terms of number of running days of data. Most our customers set it up for a week at a time or 3 days at a time. So this is set up for a week. Okay, so this is the pressure that's coming in, and it is monitoring pressure at 15-minute intervals, meaning it's sampling continuously, and then it's taking an average of those samples over a 15-minute period of time, and it will give you the data. So you can look at the data this way if you like. A lot of people like to look at it in a table form. So if I click on table, as I scroll across, you can see that it's getting the measurements in 15-minute intervals. Now, you've got the ability to configure this any way you'd like. You've got the ability to configure your sample rate. You've got the ability to configure your reporting rate. You can set thresholds for alarms. You can set your call-in schedules. You can set your transient thresholds. So you've got complete control over this if you want. So this is kind of a view of what that pressure. So if I look at this and I'm an operator, I'm pretty happy, right? Everything looks very, very stable in this one particular location. No transients, no instability. Now, if I want to get a little more granulated view, I would just hold my cursor down and go over the top of it, and you get a little bit better data coming in. But this is a very stable location. So let's go to another one and take a look and see what this one looks like. Okay, so this is completely different, okay? So this is, again, this is actually a month-long report. So if I want to change the dates of it, let's see, January 1, we'll leave it at January 1, and we'll take it to, say, January 7th. This will change the dates for me. So if I look at this, the red is my pressure reading. So this looks completely different, right? So there's something definitely going on in this network. You can see all the big swings in pressure that are occurring. If I zoom in even a little bit more, you can see these spikes going on. And now I'm seeing If I hover over the S5, which is an indication of the impulse itself, it's going to give me a summary of that impulse. So what it says is that the transient occurred at 4:39 a.m. in the morning on January 1, lasted for 267 seconds. And the swing in pressure was from about 71 psi, all the way up to 114 psi. So there's about a 44 psi change in that water hammer. So if I think in terms of taking a hammer and pounding on the pipe at 40 pounds of pressure, that if something isn't done about that, and you continue to let those water hammers continually degrade your pipe, it's really not a matter of if, it's just going to be a matter of when you're going to start to see some small leaks and eventually cracks in your pipe. So if I re-zoom in on here, so you can see in this period of time, in this 1 week period of time, I had 25 water hammers during that period. Now, if I want to look at my impulses, I would click on my impulses, and then I could look at each one of them individually. So let's take a look at the first one. This one occurred on the 1st at 4:39, the one we were just looking at. But if I want to get a higher resolution of it, I would double click it. And now, let me take, I'm going to take this off of here. So this happened in milliseconds, right? This happened in, it's monitoring this like 32 times a second. So you can see that we measure the transient right before it happens, then right up to the time the transient happens. You can see the big spike right here. It got up to 114 psi, and then it shot down again to 71 psi, and then it leveled out again, right? The only way you can capture this is with that sampling rate being that high, because this is happening in milliseconds, well under a second. So that gives you a pretty good indication of the intensity of that transient. So again, if I want to look at another transient, I would click on my view impulses. Got another one that occurred at 10:45 a.m. later in the morning. And I'm going to turn off this. And again, you can see what the real transient looks like. So the pressure was down in the 70s. Then the water hammer happened. It went up to 92 and then started moving through the system, vibrating through the system, and then leveled out again back in the 70s again, right in here. So let me stop real quickly. I just want to see if anybody's got any question on transients at all.
Okay, I'm looking at the question pane. Let me see if we have any specific to this. And it doesn't look like we do, so go ahead and proceed.
Okay, great. So let me show you a PRV. Okay. Again, the same data that you have. I'm going to bring up the default report. So this is monitoring inlet pressure, which is up here on top. That's the high side, coming in at about 140. And then this is the low side. So it's kind of jumping around a little bit. Let's see what it's doing here. So it's jumping from 80 down to about 67. So don't see any transients in here, which is good. See a little bit of instability in the outlet pressure. I think ideally you would want to see a very, very level graph where you're not seeing a lot of pressure changes going on. So this might be an indication that something might be not working exactly properly in your system. Might be a good idea to go out and do a little preventative maintenance on it. Okay, let me resume. So let me just show you a couple of other features in the software. Again, we talked about the transients. If you wanted to get a summary, which is a nice feature, it will give you a summary for that period of time. The minimum pressure was 128, the maximum 145, the outlet was 55 and 81. So that gives you a pretty good summary of the data, good averages of what was going on. I can view a variety of different measurements if I want. So this default report was just set up to show inlet and outlet pressures, but you can add call schedules to it, humidity, local battery, modem on time. There's a variety of different things. So if I wanted to, for example, add my call schedule to it, this is the call schedule right here. So it's bringing up when the calls were made in here. Okay. All right. So very quickly, I'll just run you through how the configurations can be set up. So you can set up your call schedules any way you would like. So this is set up for calling in every 3 hours. Say I wanted to change it and have it call in every 5 hours, for example. I would just change that to that. And then I would hit apply or update. I'm not going to do it because I don't want to change what's in here already. These are the sample rates that you can monitor. So your sample, it's sampling once a minute. If I wanted to increase the sample rate, I can certainly do that. If I wanted to go to 4 times a second, 8 times a second, once a second, I can do that. So it's not set at a very high sample rate, but you've got the ability to change that. And you can go all the way to 32 times a second in a PRV if you wanted to monitor for transients. The recording rate, this is set up at every 5 minutes, meaning that it's taking an average of all the sample rates and recording them every 5 minutes. Now I can change that if I'd like. So I have 2 channels, an outlet and an inlet, so I can certainly change that. I have the ability to set up my alarms on here too. So if I wanted to set up an alarm, the first thing I do is enable the alarm. I would put the threshold in there, meaning, I can just use a number. You wanted it to alarm when it gets to 100 PSI, okay? And the sample count would be, how many samples do you want it to be at? And then the distribution, you would set up your distribution of who you wanted that alarm to go to. You have 4 different alarms. You've got 2 channels here, so you've got inlet and outlet. So you can create a lot of alarms and have them go out to different people, okay? Now the impulse rate is when do you want them to detect a transient? At what pressure change do you want it to happen? So it might be 20 PSI, 50 PSI, whatever rate you want it at to. This is set at 17 PSI for 20 samples, okay? So you've got complete configuration, ability to configure your alarms, your call schedules, your sample rates, your reporting rates. You have complete control over the software. It all can be done right at your laptop. Okay, I think that pretty much is it, Steve. I think we're running out of time. I just wanted to give everybody a quick overview. I will say this for everybody that's on the call. If you're interested in learning a little bit more, then you could certainly reach out to Steve. Steve knows the product very well. One of the things that we have had great success with many of our customers is if you are really quite serious about it, but you want to you want to kind of see it in action before you make a decision on making a purchase, is that we have a nice demo setup that we can go out on site, put like a hydrant recorder on site for you, leave it out there for, you know, a period of time, give you access to the software so that you can monitor the software yourself. And that gives you, you know, a good evaluation of the system itself and helps you make a determination on whether this is something that will work well for your system. So we're happy to do that. Steve is available to be able to work with you in your territory, and he would be happy to work with you and trying to set up any kind of demo that you would like to see. And I think that's it. I hit 10 o'clock right on the button, Steve. I think I did it right in time.
Great. Yeah, thank you for your time, Dave. I'm going to look at the question pane and see if we have any more that have come in here. Here's one here. Is Timble using their own cellular network or a national carrier? Do you want to address that, Dave?
Yeah, sure. So we work with national carriers. So we work with our most widely used carrier is Verizon. So right now, everything is set up on 4G LTE. We also work with Sprint, same thing, 4G LTE. Now, you know, these networks and technology are rapidly changing, and as they rapidly change, we add the ability to talk to all those networks. So there are several new technologies that are going to be introduced probably within the next 6 months. I'm not familiar with all the details of them, but essentially these would be improvements over 4G LTE. I don't know when 5G would be made available, but we kind of will stay up with all the new modems. So the nice thing about our hardware is if you have like LTE 4G right now, and you wanted to upgrade to, say, the latest and greatest new technology, you can upgrade your modem. It's a simple swap out for modems, and you don't have to replace the equipment itself. You would just replace the modem itself. So those are the main networks we work with right now. We're taking a look at some of the other major carriers, which we may be working with in the near future, but for right now, it's Sprint and Verizon.
Great. Thank you, Dave. And just to reiterate, I show my contact information on the screen, and my counterpart in Idaho, you can contact him as well if you have any questions. Well, also, we've recorded this webinar, so there will be a recording placed on our YouTube channel, and the software service will send out an automatic follow-up email. So if you have additional associates that want to view that, you can just forward that link to them, or if you want a review of it, you can go ahead and go out there and check out that recording as well. So thank you very much for your time today. Thanks, Dave, for the presentation, and we look forward to having you on future Frontier Precision webinars.
Thanks, everybody. I appreciate it, Steve. Thank you, everybody in the audience, for your time.
Thank you. Bye now.
Bye.